So now let us understand quickly a few high level things basically, right? And what are those high level things? If data is provided to you, if the data is structured meaning it's having a neat structure, rows and tables. That's structured. Okay. If you have the structured data, if it is not very big, then you can store it on your relational database management systems like MySQL or MS SQL or Oracle database, etc. But if you have big data, then you need to use Hadoop. If you have data which is unstructured could be what? Audio files, video files, images, or your raw textual data. If you have any of these unstructured data, which is not big, right, which is not at all big, I mean, sizable, for example, then you store it in something called as MongoDB. If it is big, you store it in Hadoop. So simply put, if you have data which is big, you store it in Hadoop. Right? That's from your structured data perspective. Then this structured data or maybe unstructured data, right, is also called as cross-sectional data if the sequence in which you get the data is immaterial. Meaning for cancer prediction, for example, a specific hospital has data of say 1,000 customers or 1,000 patients rather. What customers? Sorry, my bad. I'm out of my. So say a specific hospital has data of 1,000 patients. You will not ask them on, hey, arrange these 1,000 patients information in the sequence in which they have visited the hospital. First person visited on say 16th Jan. Second person visited on 18th Jan. Third person visited on 1st Feb. In that way, you do not want your data in a sequence, right? You don't want your data in that specific sequence. So timestamp is not material, is not important. If that is the case, then it is called as cross-sectional data. If the sequence in which you get the data, for example, if someone asks me on what will be the temperature tomorrow here in Hyderabad, then I obviously need the previous historical data in the sequence. I obviously need information on what was temperature yesterday, what was temperature 2 days back, 3 days back, 4 days back, 5 days back, 6 days back, in that sequence. So until and unless you have data which is arranged in a sequence, you do not call it as time series data. And when you have time series data, we implement forecasting techniques. So you should now be able to tell me on what is the difference between structured, unstructured, big, not big, what databases you use, cross-sectional and time series. Say for example, you have 100 MB Excel file. Maybe you can open it if you have 16 GB RAM or 32 GB RAM or even 4 GB RAM, you can open that. But the moment you try out some operation such as a pivot table, your system kind of hangs. So what do? Basically, you will say that, okay, this is not working. Let me go to maybe SQL database. I'll store the data now in SQL database. Even in SQL database, until certain GB of data, it works. Say 1 TB data. Then your SQL also will start crying. When I say crying, its performance dips drastically, right? So you'll think about what else can I use? Okay, let me upgrade the server. You upgraded the server to the extent possible, beyond which upgradation is not possible, right? And you have data which is increasing in size, which on which you are not able to perform certain operations. So then you are entering into a problem called as big data problem, right? You have all those 5 V's or 4 V's, all that. But that aside, any data which you are not able to save on your machines and any data on which you are not able to do your work. For example, you need to send daily report on how was the sales for the different categories, right? And if you use your MySQL, if your system is crashing or if it's not generating reports on time, if it's taking 3 hours, 4 hours to generate a simple report, that means you have entered into big data problem. Okay, don't take big data as a literal meaning of zettabytes, petabytes, exabytes of data, right? It need not be that. For example, your hard drive, you must be having probably 1 terabyte data. Then if I give you 10 terabyte data, where will you store that? You cannot say that 10 terabyte, it's small data. Okay, for your context, for your machine, for your laptop, it's a big data problem for you. Hope I'm able to. I have, I'm using currently what 256 plus 128 would be. Yeah, one more thing that I wanted to tell you is within structured data, each row is called as an instance or a record or a case. Row, record, case, instance all mean the same. Then you have columns. Each column is called as an attribute, a feature, or variable. And the output that you're trying to predict is called as class or outcome. I'm giving you just quick minute to sink in these concepts. How much ever I say that, post the training, you guys have to go through the recorded videos at least once so that, concepts sink into you. I'm pretty sure majority of them will not do that. So that's why I'm giving you a quick 1 minute or 2 minutes here and there so that you absorb these concepts. Make a note, write it down even if you're not able to understand anything. Typically, your data science, a typical data science program has all of these, right? You have supervised, unsupervised, and time series. To become a decent data scientist, you need to learn at least these algorithms that are listed down here: decision tree, random forest, regression techniques, extreme gradient boosting, ensemble models, right? All of these. And within unsupervised learning, you need all of these. And then time series techniques, you have these bunch of time series techniques. However, when it comes to your deep learning techniques, okay, but before I go to those techniques, here is a question. What if you want to predict multiple outputs at one? See, each time you need not always predict a single output. You might want to predict multiple outputs. That's called as multi-target regression. A few of the examples could be in testing the water quality. When you want to test the water quality, you want to know what are the various chemicals which are present in the water, drinking water, right? Bisleri water, Kinley water bottle, any of those, right? When you want to test the water quality, what do? You have to look at what are the various chemicals within that. You just don't want give me a probability of different chemicals. That is not what you want. You want to know what are the various chemicals that you want. And usually when it comes to water quality, you'll have 16, 17 chemical parameters that you need to you know predict on what chemicals are there. Okay, same is the case with say employment. You want to know say how many full-time employees you want for software for a specific project. How many junior resources, how many senior resources, how many project managers, how many tech leads you want. Predict at one go given the various inputs. Making sense? So that's called as multi-target regression. So from our AI or deep learning perspective, someone had this question on, hey, tell me first of all, what concepts are you going to cover? Oh, we are going to cover all these concepts as part of data mining, basically. We have supervised learning techniques, unsupervised learning techniques, and time series techniques, right? When it comes to supervised learning, perceptron, multi-layered perceptron, convolution neural network, RNN, LSTM, GRUs. And when it comes to unsupervised learning, you have all of these: autoencoders, RBM, Debian, GANs, etc. And then you have time series. Make a note of these and let me know if I miss out on any of these. I think reinforcement learning is something that's missing, but yeah, nevertheless. Okay. So these are the various concepts that we are going to learn. Computer vision would also consume significant portion of our training.